Okay, good. Okay, so first, let's go to our homework. Previously, actually, I planned to talk about the homework, but some students emailed me saying, right now you haven't get your textbook. So they asked, can I postpone a little bit the deadline? And yes, I can give you 1 or 2 days so that you can get your textbook and finish your homework. And also because of that, today I'm not going to discuss the answer of those homework. I will talk about homework answer when all the students submitted their homework. Okay, so maybe Wednesday or maybe Friday. And next, last week, we discussed the computer architecture, including CPU, memory, storage, input, output, motherboard, and operating system, and so on. So yesterday, we also discussed, last week, we discussed our first C programming C program. This is a very simple C program. Like I include the library, and then from int min, that is the start of my code. That is where the compiler, that is where we start to execute the code from min. And then for this simple code, I just print out hello world to my terminal using the command cout hello world. And then I end up the program using return 0. So this code is doing nothing but just print out hello world to terminal. And also we discussed the comments is very important because that helps others and yourself to understand your code. So write a very good comment all the time when you write your code. Also, last week, we discussed a little bit the special characters when we write our code. For example, the parentheses. That is usually used for first one, put your arguments. Second, for some math expressions. For example, in this example, you can say after min, keyword min here, I have parentheses. And this place is used to send some arguments to this main function. But for this example, because I don't need any argument, so I leave this empty. Later on, you will see for some situations, we will put argument in this parenthesis. And also, these characters can also be used for math expression. You will see it later because here in this code, I don't have any math expression. Also, we talked about this close and or open braces. This usually is used for function. For example, here, for main function, you can say all the lines included by this main function is included by this pair of braces. Also, we have quote marks, either double quote marks or single quote marks. And the difference is usually the double quote marks is used for a string. For example, here, hello world. This is a string, so I'm using double quotes. Sometimes if you only have one letter, you have a single character, then we will use a single quote. And also, maybe one of the most important character is this semicolon. Semicolon. Usually, semicolon is the end of every line, except include. So, except include, every line we will end up with this semicolon. So, those are the characters. And you may want to pay attention to all those later on when you write your codes. Okay, last week we also discussed to output some sentences, some words to the terminal. Our syntax is say out, and you have smaller sign, hello world. All those ways work. For example, hello world in one double quote, or hello and also another smaller world, or say out hello, and in the next line I put say out world. All those three different methods give us the same result. They all just output hello world in the terminal, as you saw last week. They have the same effect, all those three different methods. Okay. This is what we discussed last week. And for this week, today, we will going to discuss variables and data type. And you also watch the video. So next part, before I start today's example, later on I will give you some examples so that you can really see what's going on if I write those code regarding the variables and the data type. And before I start my examples, I want to ask, is there any questions regarding the video? So if you have any question, ask me and we will discuss it.
It's just simple, but why would you ever use int if you can use float to include the same thing?
Okay. Main reason is int will be calculated faster. And also int, because there's no, there's just int, and it will give us a higher range to express numbers. For example, okay, let me go to our slides video. Here, not this one. Here it is. So, if you look at this picture shows how large we can express using int. So it's kind of 2 billion, right? And this is int. But if you use float, you couldn't go to that big number. You couldn't go to that big number. You will have some like after the dot, you will have 2.387, something like that. But the maximum of the number, you will not go to billions. The second reason it will be calculated slower compared to int. So that is why. So if your data type is int, you use int. If your data type is float, you will use floating point number. Yeah.
Thank you.
Sure. Good question. Yes. Other questions? Okay. So if we are good with all those points here, I'm going to go to the example. Make sure you make clear regarding each slice of this document. So because those are very important. And later on, we will use this knowledge. If you don't ask now, I assume you are good with all those points. So I will just use those knowledge. In that way, I don't want you feel confused. So make sure you are good with every slice here. Okay. Another question. I wonder, have you guys already learned a binary expression?
I've only learned a little bit of binary.
Okay, so for example, if I say decimal 3, what is the binary? No answer? 3 in decimal. What is the binary expression of 3?
Would that be 1, 1?
Yes, correct. That is 1, 1. So, is everybody with this or no? Is everybody good with how to convert decimal to binary, or not everybody is good with this? I just want to know so that I know how do I teach, how do I make you feel good about the following contents.
Can you explain that much?
You said can I explain a little bit?
Yes, please.
Okay, sure. Okay, for this class, actually, this binary decimal conversion is not our point. We probably will use a little bit. So if you don't feel you're very clear with this, don't worry about that. It's fine. I just want to know how good you are with that so that I will know later, should I explain more or I don't need to explain, use time on that. So that is the point I'm asking this question. About how to convert is, maybe you need to express a little bit. For example, if I say 1 in decimal, that is 1. Okay, I will write it here a little bit. Decimal and binary. 0, 0, 1, 1, 2, 1, 2, 3, 1, 1, 4, 1, 0, 0, 5, 1, 0, 1, 6, 1, 1, 0, 7, 1, 1, 1, 8, 1, 0, 0, 0. I know it's confusing if this is your first time to talk about this, but for now you can just a little bit remember this, and later on, maybe after the class, you can go to Google and try to understand how this conversion goes. What is the theory behind it? Because for this class, our point is not to explain the theory about how to convert a decimal to binary and worse, and so on. But just one point is, for the binary, you can see on the right is my binary. For binary, you only have 1 and 0. This is what we discussed in the previous class. We said in machine code, in the code that computer can understand, computer only get 0 and 1. Computer couldn't read nothing more than 0 and 1. If you tell computer 2, actually computer doesn't understand. So you have to convert 2 to binary, which is 1, 0. And the computer only understands 1, 0. So eventually, all our numbers, letters, sentences, image, video, picture, everything, audio, will be eventually converted to binary to send it to computer so that the computer understands. And this example only shows how do I convert a number, decimal number, to binary sequence. So, okay. So now this is my binary. Okay. Now, do you have questions? If you don't have a question, I'm going to go to our examples. Okay. So I'm going to use my visual code, VS Code. Open my VS Code. So now here, you can see this is one example. This example, you can find it in Blackboard. So here, similar, like we mentioned before, all those green lines, now you can see those green lines, They started with double slash. So that is what we mentioned, comments. Comment will not be executed by the VS Code, by the compiler. So like here, those lines are only used for human being to read it, to understand the code. It will not be executed. Like here, I can put a lot of slash. The first line, it's just for neat, for pretty, for being neat, for it looks better. It's nothing, so I can delete it, no problem. For example, like this, I can delete it. It will not impact my code. It impacts nothing. So those you can do whatever you want. And the real code, the part that will impact our code started from include. Like we mentioned, this include IO stream library. This library is used for print out something on the terminal, and the terminal is here. On the bottom part, this is my terminal. You can see terminal, yeah. And also, like we mentioned, using namespace std, that means for some functions provided by compiler, the name will be standard. The name will be defined by the standard namespace. That is why I'm using namespace std. Okay, the next 4 lines are again comments. And then our main code started from here, main function. So still, for this main function, now I'm not using any argument. So inside this parenthesis is empty. And the main body of the main code is included by a pair of braces. Start here, end it here. So this is my main code. Okay, so first let me execute it a bit so you can see. Build and run. So now I got some result. Here is my result. Exercise 1, 2 until 6. This is my result. So now I'm going to explain one by one. Let me first, okay, this is my main function. So first, let me comment out some lines. From this sentence, remember last time we mentioned, you use slash plus a star sign, and then at the end of here, it's always used in pair. So I use the one at that point, I'm going to use another one. So what I'm doing now, I put a star slash here, started from a slash star here. That means from this line, from example 2 until example 6, I'm going to comment it out. That means I'm not going to execute it. The only line for now I'm going to execute is example 1. So before, the running result is here. But what's going to happen now? Let us run this. First build and then run. So you only have one line of output. I only get one line of in output because other examples I commented out. So what is example 1? Simple. Say out exercise 1 hello 171 end. That means yes, I just want to send out a sentence. This is exactly the same as our previous hello world example, right? I just changed the sentence I want to output, but the syntax are the same. Okay, so now I'm going to move this to here. Now you can see I removed the start of the comment from this line to this line. So now I'm supposed to output example 1 and example 2. What is example 2? We mentioned first we have a variable x. And this is how do you define a variable. First, you have to tell the computer what is the type of this variable. So I'm going to use integer. So integer, the syntax is int. Int means x is an integer. And I put an initial number to this integer, which is 5. So later on, what I'm going to do is I will print out first some sentence, exercise 2, x stores what? Then you will see the syntax is smaller, and x, and then n. So what it is going to print out is first exercise 2, x stores the number of x, the value of x. For this example is 5. So let's run this. Run test. Okay, look at here. Exercise 2, x stores is here, and then x. Okay, so of course I can change here. See, I just do some random change. I put a really. So I just want you to see, I can change the sentence here. So here, x stores really 5, right? So you can change this part as much as you want. And also x. Now this is a very common way for us to initialize a variable and give a number, give a value to this variable. Of course, actually what you can do is you can also do this. See, I do the same thing but using 2 lines. First, I initialize x. I defined a variable, an integer, which is x. And in the next line, I give a number to this x. This works exactly the same, no difference. I run it again. See, the output is same. There's no difference. Okay, for this part, question? You can still see my screen, right? Thank you. Yeah, perfect. Thank you. Okay, then I'm going to go to the next example. Next example is still this x. X was 5, and now I'm going to do some math calculation. X plus 1, and the result will be sent back to x. X was 5, and I plus 1 to x, and send the result back to x. And then I print out. So now you can see x is 6. Okay, this is still simple. Let's go to the next example. Okay, before I run this result, can somebody tell me for this example exercise 4, what is the result? If I run this code now, what's gonna be printed out? Can somebody give me an answer?
It's either going to add 1 or is the function going to cancel out? And I mean, like have an error, because when you were talking about defining integers, it can only go up to a certain number. If I was not mistaken.
Yeah, I like your answer, but I don't think it's right. But I like your thinking. It's a good way to think about those kind of questions. But you may see a surprising result. Let's see.
Is it going to be negative?
Yes, it's going to be negative. Yes. I think you will find that your answer is right. See, now look at this. It's very cool. Still this number, but negative. Why? Go to that slice. Here, see, this is that number. Okay. This is that number. 2,187,000,000, blah, blah, blah. And then if I plus 1 to this number, the next number gonna be this guy. Negative 2,147,000,000, blah, blah, blah. And so on. Gonna be this number. So this is signed integer. We started from 0. 0 plus 1 is 1. 1 plus 1 is 2. 2 plus 1 is 3. And so on. You go to this number. And this number is the maximum positive number we can express in a signed integer. If you plus 1 to this number, the next number is going to be negative, this one. So, let's see. If I add a little bit of code here, x equal to x plus 1, I'm doing it again, and print out. Let's see. The initial number is this number. I plus 1, it becomes negative, this guy. And I plus 1 again and print it out. See what's going to happen. See, now again it's this number, 47. Previously it was positive something, a long number, and 48. Plus 1 is negative 48. Plus 1 again is negative 47. So go to that slice. Oh, 48. There's 48. We didn't show in this slice. The maximum number is 2 billion blah 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 648, as shown by this program. 48. Yeah, negative 48. The 47 is the maximum positive number. Plus 1, it becomes negative 2 billion blah blah 48. And then plus 1 again becomes negative 2 billion blah blah 47. And if you do it again, it will become negative 2 billion blah blah 46. So this, I know you feel confusing. Why? How this comes out? This have to go back to how do we express negative number in binary. And it's complicated. How do you express negative number? See, previously I showed you this. I showed you this. How do you express number in binary? But now all my decimal numbers, they are positive. What if decimal numbers are negative? And then how do you express it in binary? That is more complicated. Only when you understand that, you can express why plus 1 becomes from negative 47 becomes negative blah 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 40, from 48 becomes 47. You can express that. And that is not our point for this course. So I'm not asking you to really understand this, understand the theory behind it. But you just say, okay, this number 2 billion blah blah 47 is the maximum number we can express using int, using a signed int. That is the only thing I want you to understand. Plus 1, it becomes a negative number. Yes, that's enough for this course. Okay. Question? No question, then I'm going to go to the next part. This part, say, x is equal to 17 divided by 4. So before I run this code, I'm going to ask what is the result for this printout. Can somebody tell me what's going to be printed out?
Undecimal.
Sorry?
Undecimal.
No, because see, the result, the division result will be stored in x, but I already defined x is an integer. So, like the video said, an integer type couldn't store a decimal, couldn't store a fractional number.
Will it do 5 and just have a remainder that is not, 4 and just have a remainder that's not going to show?
Yes, it's gonna be 4. Yes, that's correct. It's gonna be 4, and all the fractional part will be cut. So, let's see that. See here, this result gonna be 4. So yes, all the fractional part will be cut because x is an integer type. An integer type can only store integers. Yes. Okay. Next one here. This one is we are going to ask what is the size of x. So example 6 is gonna print out how large x is. So before I run it out, can somebody tell me what is the result? By the way, okay, here, this function, sizeof in the parentheses, there's x. That is a function provided by compiler. This function just extract the size of x. Okay, how large x is. So this is a function provided by the compiler. It gets the size of x. So now what we are going to do is first print out one sentence. Exercise 6, x requires, and then the size of x, and then how many bytes of memory. So now my question is, what is the size of x? We mentioned this in video. Okay. Here, x requires 4 bytes of memory, and here this 4 is the result of size of x. Size of x give me a 4. So another question, can somebody tell me how many bits 1 byte has? How many bits 1 byte has?
8-bit.
Yes, good answer, 8-bit. And 1 bit is just 101, either 1 or 0. Okay, I'm going to show this here. This is 1 byte. 1, 2, 3, 4, 5, 6, 7, 8. Yeah. 0, 1, 0, 1, 0, 1, 0, 1. It's either 1 or 0 for each bit. It doesn't matter. I just want to tell you there are 8 digits in 1 byte. And each digit is either 1 or 0. That is 1 byte. So, like we mentioned, the int type have 4 bytes. 4 bytes. So what does it mean? That means this is 1 byte, right? You have the second byte, 0, 0, 0, 0, 0, 0, 0, 0. This is another byte. and then 11111111, another byte, and then 11111111, another byte. So this is 1 byte. This is 1 byte. Okay, now what you are looking at, this part, is int in binary. One int type variable, but in binary. And this number, I just randomly wrote some 0 and 1. If you convert this to decimal, then you will get what is this number is. I don't know what his number is. I just randomly write it. I don't know. So if you convert it to the decimal, you're going to get the decimal number of that int. Maybe your int x. That is what does it mean when we say 4 bytes. Now this is 4 bytes. Four bytes actually is 32 bits because each byte has 8 bits. 32 bits together, put together is one int, signed int. Okay. Okay. Now I'm going to go to my next example. Float. First, I will still run it. Okay, so first, exercise 1, we just print out exercise 1 illustrate of floats. So here, this is the result of exercise 1. And then I will still code something out to make it easier to read. Okay, exercise 2, first I defined another variable, myPy, and now look at here. The keyword in front of myPy is just the name of the variable, right? And in front of it, I put a float, because now myPy is not an integer, it's a float. So I put a float, and then I give a number, I give a value to myPy, this number, and then I print it out, myPy. And then you can see the result. MyPy stores 3.14159. So now you probably notice that when I define MyPy, I give a lot of fractional parts. But when I print it out, the numbers after 9 was cut off. The reason is still because of the storage. For MyPy, which is a float, it also requires 4 bytes in the storage. And that 4 bytes couldn't store as long as you want. Like you want to store a lot of fractional parts digits. It doesn't work. It usually will have like 6 or 7 digits, including the whole number parts. So if you have longer than maybe 6 or 7 digits, it will be cut off. But either it will be 6 or 7, it depends. It's just about 6 or 7 digits can be stored in a floating point number. Okay? Next one. So next one, you can see, still I want to know how large my pi is. So I'm using the same syntax, size of, using the same function. And now it print out my pi requires 4 bytes of memory. So though this also was mentioned in the video, we mentioned that for floating point number variables, it requires 4 bytes. Similar as integer, signed integer, still use 4 bytes to store the number. And that explains, since you are going to store some fractional parts, so of course the maximum number for floating point number is going to be smaller than the integers. Then I'm going to some simple calculation. Okay, I put the comment here. Okay, next part, look at here. I defined 4 floating point number, radius, area, cost, and value. I defined 4 numbers. So of course, you can define the number, the variable as my pi or x, or give some name which can indicate the meaning. And now I'm defining 4 variables. And then I give some numbers. The radius is 9.5. And then for the area, I'm doing some calculation, which is pi times radius times radius. Right, that is our math function. How do you calculate the area of a circle? And then I tell you the cost is 5.99, and the value is the cost divided by the area. And then I print out the 9.5 size inches pizza has a value of here. So let's print this out. So now you can see the 9.5 inch pizza has a value of this number per square inch. And this number, 0.0211 something, is this value. And how does this value come? Value is calculated as cost divided by the area. And the cost, I defined it as 5.99. Area is something I calculated. And then cost divided by the area is the value. And then I print out value out. So I just want to know how much for each square inch of that pizza. Question? Is there any question here?
No, I got it.
Okay, cool. Then the next 2 parts are the same actually. Say, first, I calculated what is the value of 9.5 inch pizza. And then I'm interested in how about 11.5 size pizza. What is that value? And then how about the 13.5 inch pizza? I want to know different values of different size of pizza. So let's print this out. Here. Look at here. I always have an arrow. Yeah. See here, when I compile it, there's an error. And the reason is I put some comments here before, right? I put something like this before. And I deleted this, but I forgot to delete this one. It's always used in a pair. So you have to delete it. Otherwise, the compiler gives you an error. So now, I just print the cost of different size of pizza. What is the cost? Yeah. Say, now you can say, using C++, you can do a lot of calculations. You can do multiplication, division, a lot of calculations. Yes, just input your function and input your initial number. And then C++ will calculate for us and give the result. Yeah. Now, those are our examples to show the data type. Okay. So, is there questions? Next class, either maybe Wednesday or maybe Friday, we will start to install our VS Code. And next Friday, not next, this Friday gonna be our first lab. So either Friday or maybe Wednesday, I will help you to install the VS Code and teach you how to compile it, how to get the result, so that you can have your own code rating. Okay, so yeah, that is today's class. Another thing is about office hour. You can find my office hour on the syllabus. And yeah, most of the time, office hour, I will stay in Discord. So you can contact me through Discord, and we can share screen to help you figure out the problems, help you to do some coding job. If you want to meet me in office, send me an email before, so probably I will still in office, but that couldn't be guaranteed. But of course, on Discord, I will always be there during office hour. So yes, if you have a problem, come to me. Okay. And if you don't have a problem, that is today's class. Thank you.